Hello everyone, I'm Erica Pinto, and today I'm here to tell you about the Strongylocentris drobachiensis. Tongue twister name, this species is more commonly referred to as the green sea urchins. First, I want you to imagine walking on the beach, smelling the seawater as the sun began to set. This is what I was doing when I encountered my first sea urchin. Let's say they didn't leave a good first impression, then again I had stepped on one. When I remember this moment, the first thing that comes to mind isn't the pain, but the marvelous creature and its defensive mechanism. This is how I began my research on sea urchins. I will show you right now why sea urchins are such marvelous animals and why the US should begin culturing them. The green sea urchin is native to Europe and in North America. At sea, they are native to the Atlantic and the Pacific. Their habitat includes sheltered rock reefs and kelp beds since they prefer habitats that protect them from surges. Juveniles tend to grow best at 9 to 13 degrees centigrade. Lethal temperatures include 19 degrees centigrade for larvae and 22 degrees centigrade for settled individuals. Urchins cannot recover from infections at 8 degrees centigrade or less. Elevated levels of CO2, nitrates, and ammonia lead to reduced growth. They can, however, tolerate low levels of these substances. Urchin eggs will complete meiosis in the ovaries and can be fertilized after spawning. One sea urchin can produce millions of eggs. The life cycle of one urchin goes as follows. 7 hours after fertilization, the egg reaches its first stage of development, called cleavage. 24 hours after fertilization, the egg reaches its second stage, called blastula. 40 hours after fertilization, the egg reaches its third and final stage, called gastrula. Once hatched, the sea urchin larvae is called a pluteus. This period lasts for about a month. The sex of a larva is impossible to distinguish until it itself begins to release either eggs or sperm during its adulthood. After the larvae stage, the urchin will enter metamorphosis, which is initiated by a chemical cue of bacterial origin. This stage will develop the urchin's spines and organs. The reproductive system begins to develop in its juvenile stage about 2 months of age. At 2 years of age, sexual reproductivity is attained, and the urchin can induce spawning when it reaches 1 centimeter in size. This is also considered the adult stage. In the wild, urchins are omnivorous and eat a wide variety of plants and animals. Urchins grow best with a diet of 16 to 20% of protein and less than 40% of carbohydrates. One other very important characteristic of the sea urchin is that it is nocturnal. Sea urchins will usually hide in holes or crevices during the day and only feed at night. They have many predators, and due to this, if the sea urchin population decreased, the sea creatures that feed on them might die out as well. A few predators that feed on sea urchins are otters, starfish, and humans. Before overfishing, sea urchins were abundant. Before people realized urchins were valuable, kelp harvesters would spread lime to kill urchins and manually crush them for kelp growth. When urchins became valuable, divers began using surface-supplied air and then used urchin rakes to pick out sea urchins from rocks. This began in the 1970s or around then. When sea urchin fishery peaked in 1990s, urchins were susceptible to overfishing. Specifically in Maine, where the sea urchin industry was the second biggest industry, second to lobsters, which was the first at the time. The first hatchery for sea urchins was created in 1998 in Maine and in New Hampshire. At its peak, 9.3 million pounds of urchins were harvested in 1990. This resulted in overharvesting in certain areas like Maine. This resulted in diminished fishery, and after the fishery boom was over, fishery landings were able to stabilize. Regulations were also put in place to avoid overfishing. Sea urchins are used in a favorite Japanese sea urchin dish called uni, often served in sushi restaurants and as a holiday treat. The dish only uses the urchin's gonads, commonly known as the reproductive system, and the rest of the urchin is sacrificed. Currently, sea urchins are very common and abundant. The population has remained steady since regulations were put into place. Overfishing is not occurring at the given time, but recent demand for urchins has declined, but average harvests of a 5-year period still bring in 2.8 million pounds of urchins. Key regulations include daily harvest limits, harvest area limits, and harvest size limits. In addition, some local areas want fishers to keep logbooks of their harvest and provide their logbooks to officials. These regulations are most effective in preserving the sea urchin population. Fishing has been sustained and hasn't affected the population yet. Since it is difficult to raise sea urchins through its metamorphosis stage, production through aquaculture is not high. However, sea urchins are the perfect candidate for aquaculture production since of the demand for high-quality urchins and the market value. In the late 1800s, several biologists succeeded in raising larvae to maturity. This was achieved through frequent seawater changes, which allowed the addition of planktonic algae as the food source. Some of these larvae developed through metamorphosis. Many scientists published books on laboratory growth of sea urchins, specifically Ralph Heingartner, who wrote Growth and Development of the Laboratory Cultured Sea Urchin. This publication includes techniques and methods of culturing sea urchins and led the way for other groundbreaking discoveries in sea urchin production. Given a surface covered by a mixture of algae and bacteria, he wrote, the mature larvae would settle and metamorphosis would commence. Once metamorphosis is complete, the young urchin's nutritional requirements were found to be quite complex, requiring more than a year for Heingartner to find an appropriate algal food that could be cultured in the laboratory. If this species were to be cultured correctly at a balanced rate, then it would only benefit the environment. We need to be careful as to not over-culture for environmental release. If we culture and release too many urchins, they can erode coral reefs and destroy them. On the other hand, culturing for release is needed because urchins are at risk of a detrimental loss in population due to overfishing, environmental changes, and etc. At this point, the green sea urchins and its habitat are not in any way threatened by the environment. However, if green sea urchins were to be reduced in population drastically, there would be mass amounts of kelp that would cause the water to be congested. This congestion does not allow boats to pass through the water, making it hard to harvest other fish. Therefore, it is important to preserve the population of this species while we still can. This is done by following key regulations, both local and federal. Make sure you are buying and consuming sustained sea urchins. Another way to preserve the sea urchin population is to begin culturing sea urchins. This includes supporting aquaculture businesses that are culturing sea urchins currently. If this species were to go extinct, other animals that rely on the species would also be harmed. These species include tigerfish, crabs, lobsters, otters, and others. This means that you will not be able to feast on your favorites because it would harm the population further. The goal should be to maintain the green sea urchin population, and now is the best time to begin green sea urchin production before they are affected by overfishing. Thank you.